All right. Hi, everybody. So today I'll be talking about abstract data types, which are also known as ADTs. So ADTs are data types that are defined only by their operations and not by their implementations. And in this way, they're very similar to an interface. So for ADTs, we don't know about the nitty-gritty details on how these data types are implemented. So we don't know about their data structures, any algorithms they use, the instance variables that they use. We only know how they work, right? And that's kind of like the key takeaway behind ADTs. So in question 5, we're told that we were hired by Ethan to help design a priority queue implementation for kelp, the new seafood review startup ordered on the timestamp of each review. And we'd like to create a data structure that supports the following operations. So the insert operation, which inserts a review in big O log n time, the edit method, which takes any one review, which edits any one review in theta 1 time, the 61 method, which returns the 61st latest review in theta 1 time. If there are fewer than 61 reviews, we return the earliest review. And finally, the poll 61 method, which remove and returns the 61st latest review in big O log n time, or the earliest review if there are fewer than 61 reviews. Okay, cool. So how does ADTs have anything to do with this question? Well, we're given these following ADTs. And notice how we don't know the exact details on how these data types are implemented. So for example, in the review class, we don't know anything about how we get the review's ID. What we do know is that we have access to this method, and we know the functionality, how this method works. And that's similar to any methods in all of these data types. Okay, so let's move on to the constructor for kelp. And we notice here that we have these 3 instance variables in kelp. We have a min heap top, we have a max heap called bot, and we have a hash map called reviews. Well, so let's kind of intuitively understand why we have these 3 data structures, or these 3 instance variables. So recall that we're trying to implement a queue that revolves around getting or returning or removing the 61st most recent reviews. So if you think about the collection of reviews that we have, we can split up this collection into 2 parts. The first part containing the 61 most recent reviews, and the second part containing reviews that are older than the 61st most recent review. And we can use a min heap to represent the 61 most recent reviews. And in this case, the 61st most recent review will be at the top of the heap. And reviews that are older than the 61st most recent review can be represented using a max heap. And in this case, the 62nd most recent review will be at the top of the heap. Okay, so that's kind of the intuition behind why we have a max heap and a min heap. What about the hash map? Well, recall that we know that the runtime for hash maps is theta 1 time, and our edit method should also take theta 1 time. So we can use this hash map to somehow edit the reviews. Okay, so going back to the constructor, in the constructor, we need to initialize all these instance variables, and that's what we do here. And the next part of the question asks us to implement the 61 method. And recall 61 should return the 61st latest review in theta 1 time. If there are fewer than 61 reviews, return the earliest review. So I'll give you, well, I would recommend you guys to try implementing this method on your own, and I will spoil the solution in 3, 2, 1. So hopefully we said that we return top.peak. And the reason this works is recall that top is the min heap that has the 61 most recent reviews. We can simply just call top.peak to either get the 61st most recent review if there are 61 or more reviews, or we can get the earliest review by also calling top.peak. Because top is a min heap, the earliest review will be at the top of the heap. let's move on to the poll61 method, and recall that the poll61 method remove and returns the 61st latest review in big O log n time, or the earliest review if there are fewer than 61 reviews. So again, I would recommend trying to implement this method on your own, and I will spoil the solution in 3, 2, 1. Okay, so hopefully this is what you got. So we see that there's this variable 61 that we're going to return in the end. So we should probably pull from the top heap, because polling, remember, removes and returns the top of the heap. The next thing we want to do is we want to remove this element from the reviews hash map. So that's what happens here. And recall, in order to call remove on a hash map, we need to call it using the key, right? And to get 61's key, we can just call 61.getID. Okay, so if there are less than 61 reviews in our, if there are less than or equal to 61 reviews in total, that means that bot.size is going to be equal to 0, right? If there are more than 61 reviews, that means bot.size is going to be greater than 0. And in the case that there are more than 61 reviews, because we've just removed the 61st 61st latest review, in our top heap, we now only have 60 of the most latest reviews. So now we gotta get this, if there are more than 61 reviews, right, we need to replace that 61st review with a new one. And that's kind of the logic in the if clause, right? If there are more than 61 reviews, we pull from the bottom heap, and that's going to be our new 61, and then we're going to add that element to our top heap. Okay, so hopefully that made sense for poll61. Let's move on to the insert method, and recall that the insert methods inserts a review in big O of log time. And again, I'd recommend working on this on your own, and I'll spoil the solution in 3, 2, 1. Okay, so hopefully this is what we got. So the first step into inserting is we need to put the review into our hash map. So we call reviews.put r.getID r. So if the top heap has less than 61 reviews, all we need to do is add r to our top heap, and there's nothing else to do. This else if clause is checking to see if r is an older review than the 61st review. So if r is an older review than the 61st review, our top heap doesn't need any modifications. So all we need to do is add r to the bottom heap. But in the case that r is more recent than the 61st review, that means that r has to be in the top heap. And that also means that the current 61st review is now going to be the 62nd review when we add r. So what we have to do is we have to pull from the top heap, which we can do by calling poll61. We can add this old 61st review into the bottom heap, and then add r into the top heap. Okay, so that's insert. Let's move on to edit. And again, let's take some time to implement this on your own, and I will spoil the answer in 3, 2, 1. So for our edit method, the first thing we need to check to see is if this ID is in our reviews hash map. If it's not in our hash map, then we just have to return out of the function. If it is in our hash map, what we do is we get the review from our hash map by calling reviews.getID. And then finally, we can call r.edit on body to edit the review. Okay, so that completes the walkthrough for question 5. Good luck on the midterm, and I'll see you guys soon.